In this video we're going to look at how to find angles. So let's have a look at an example. Let's try and find the angle theta in the triangle below. What we'll do is mark that angle theta with an eyeball shape, and that's looking at the opposite side. So the eyeball looks across here to the opposite side. That's 10. The hypotenuse is the longest side, and that leaves the adjacent side as 5. Using SOHCAHTOA, you'll notice I've placed a tick next to O here and here because I have this opposite side of 10. I'm also going to place a tick next to the letter A because I have the adjacent side. That means I'm going to use the tan ratio, which is the opposite over the adjacent, 10 over 5. That gives me a value of 2. To find the actual angle, I need to take the inverse tan of 2, and that gives me 63.4 degrees. Now we're going to look at some trigonometry of composite shapes. That is, shapes that contain or are composed of more than one article. Now for problems where the right angle triangles are hidden in the diagram or part of a more complex diagram, it's actually helpful to look for sloping lines, as these often represent the hypotenuse. So let's have a look at example 1, where we want to find the height of the tent shown, which has a base of 150 centimeters and sloping edges which meet at 40 degrees. So I've marked 150 there on the tent at the base, 150 centimeters, and the angle of 40. Now I'm going to draw that triangle showing the angle of 40, and I need to create a right angle triangle. So I drop a line down the center, splitting that triangle in half. Notice that the base of this new triangle is going to be 75 centimeters, and I'm splitting that angle to make this angle here from here to here 20. So I'm just going to draw the right angle triangle that I'm going to use in my calculation. Notice that I've marked out the opposite side as 75. That's where the eyeball is looking. The hypotenuse I don't know, and the adjacent side I don't know. Now in this question, the aim was to find the height of the tent. So the adjacent side is the one I want to find. I write out SOHCAHTOA, and I'm going to place ticks next to what I know. I know the opposite side, so I've ticked that. I wanted to find the adjacent side, which is labelled X on my diagram, so I've ticked that. I'm going to use the tan ratio because tan includes opposite and adjacent. So I've written tan 20 equals 75 over X. Because X is on the bottom, I'm going to divide. So X is 75 divided by tan 20, which gives me 206.06 centimeters. In the next example, I'm going to find the values of A and B. Now looking at those two triangles, I have some information about each of them. The bottom triangle, I know that the base here is 12, and I know an angle of 70. Whereas the top triangle, the only thing I know is this angle here. So I'm going to start by working on this bottom triangle. So using the bottom triangle, I'm going to use sine. Now the reason I'm going to use sine is because if that angle was an eyeball, it's looking at the opposite side, and I want to find the hypotenuse. So opposite and hypotenuse are relevant. You can see here where I've drawn SOHCAHTOA, I've put a tick next to the opposite side and a tick next to hypotenuse. And after doing that calculation, we had sine 70 is 12 over A, opposite on hypotenuse, So A is equal to 12 divided by sine 70. So A is 12.77. Now that I know more about this bottom triangle, in other words, I know this length here of A, that is also common to the triangle above. So over here on my second diagram, I've marked in the side of 12.77 that I now know, and I'm going to use this angle of 50, and that means this side is now opposite this angle, so I'm going to label this as the opposite side, and I'm going to label B as the hypotenuse. A is labelled for the adjacent side. Now notice that I've put some ticks in here because I knew the opposite side. I've ticked O here and here, and I wanted to find the hypotenuse, so that's relevant to me, so I've ticked H here and here. Notice that the sine ratio has 2 ticks, so I'm going to do sine of this angle 50. So sine of 50 is opposite side over hypotenuse, and to find the value of B, because it was on the bottom of the fraction, I need to divide. So B is equal to 12.77 over sine of 50, which gives me 16.43.